Okay, the last thing we can use for the last thing I want to cover today is what we call z-scores. Z-scores make use of our standard deviation. Okay? So the standard deviation is a measure of spread that tells us kind of the typical distance from the mean. A z-score tells us a measurement that we have, how different it is from the mean, but not in just units, but in standard deviations. Okay? So when I said, if I said the average income is $50,000 per year, and you make $40,000 per year, your difference from the mean is $10,000 less than the average. Okay? But rather than just saying 10,000 less than the average, we might try to express this in in terms of standard deviations. Okay? And so let's say the standard deviation for income was $20,000. Okay? Average is 50, you make 40,000. Okay? And the standard deviation is 20,000. How many standard deviations are you different from the average?
Half.
You are half of a standard deviation different. Does that make sense? Okay? Because you are making 10,000 less than average, but each standard deviation is 20,000, so you are 1/2 of a standard deviation below average. Okay? Somebody who makes $90,000 per year, what is their how many standard deviations are they away from the mean?
2.
They are 2 standard deviations above the mean. Okay. Are we following this conversation, kind of? No? Okay. No. Yes, no. Some of you are nodding yes, others of you are shaking your head no. Okay, so I'll try to illustrate this, okay? So z-scores, they tell us how different they tell us, how far a number is from the mean in standard deviations. Or the definition of a z-score. A z-score is how many standard deviations a point is from the mean. Okay, so here, let's try an example here. Okay? Let's say the average height of males in the United States is 70 inches. So that's 5'10". Okay? And we will say the standard deviation for height is 3 inches. Okay? So if someone is 5'7", so they are 67 inches. Okay? How much shorter than the mean is this person?
Standard deviation.
Yeah, this person is 3 inches shorter than average. Or we can also express it as this person is 1 standard deviation below average. Three inches below average. This person is 1 standard deviation below average. These are both saying the same thing, except one, we are expressing that distance in standard deviations rather than the raw unit. I want to make sure that this statement, along with this setup, makes sense to everyone. So can everyone see that?
Yes.
The mean is 70, the standard deviation is 3, someone over here is 67 inches, that person is 3 inches below average, or, in other words, that person is 1 standard deviation below average. Okay, so if I say, if I ask what is the z-score of someone who is 72 inches tall. So someone is 6 feet tall. What is this person's z-score? How many standard deviations from the mean is this person?
2/3.
Yeah, okay. So this person has a z-score equal to 2/3. I just want to make sure that's okay. We're all okay with fractions here. Or if we don't like fractions, we could say 0.667. Is that better? Okay. Now, how did I get that?
Standard for a whole is 3, and it's only 2 over.
Yeah, so we took the distance from the mean. We said 72 minus 70 is equal to 2 inches, okay? But we don't want the distance in inches, we want the distance expressed in standard deviations. Each standard deviation is 3 inches, so we do 2 divided by 3 and we get 0.667. Okay. Is that okay? So going back to this person who's 5'7" or 67 inches, what's this person's z-score?
1.
Negative 1, actually. Okay, so this person has a z-score of -1 because he is 1 standard deviation below the average. Is that okay? Okay? Alright, so the z-scores allow us to compare apples to oranges, okay? In that we can take two things that are different, but if we know the mean and standard deviation of each of those things, we can then say, you know, what's more unusual, okay? So, what would be more unusual? A woman who is 6'2", or a man who's 6'5"?
A woman.
Okay, so the murmuring seems to be that the woman who's 6'2" is more unusual than the man who's 6'5", okay? We would both consider both people to be very tall, right? So a man who's 6'5" is quite a bit taller than average. A woman who's 6'2" is also quite a bit taller than average. But something in our intuition says the woman who is 6'2" is more unusual, or, more unusual than the man who's 6'5". Is that what I said? Okay, so we can verify that by using z-scores, okay? Is what I'm saying and proposing to do, is that okay with everyone? Alright, so let's say we're going to do that, okay? So 74 inches tall. For a man who is 6'5", 77 inches tall. Okay. So both are very tall people, but which one's more unusual? Okay. So to answer this, we would need to know some information about women in general. So women, we will say the mean is 64 inches, 5'4", with a standard deviation, let's say 3.1 inches. Okay, and then for men, the mean, we're going to say is 70 inches, and the standard deviation is 3 inches. Okay. So what is the z-score of a woman who is 74 inches?
3.
Okay, so what we would do is we would say z is equal to the point x minus the mean x bar divided by the standard deviation. And the symbol for standard deviation is s. Okay, so z is equal to x minus x bar over s. Okay, so x minus the mean divided by the standard deviation. This is one way to find the z-score. So over here we would say this woman is 74 inches tall, and we subtract off the mean of 64 inches, and we divide by 3.1, so we get 10 over 3.1, and we get, I don't know, 3 point something. 3.25. 3.225. So this woman has a z-score of 3.225. That's the woman's z-score. The man, so this is z-score of woman. Okay. All right, go ahead and find the z-score of the man. 77 inches tall.
2.13.
Okay, so we do z is equal to 77 minus 70 divided by 3. 7 over 3, we get 2.333. Okay, that's the z-score of the man. And so we would look at the 3.225, look at the 2.33 of the man, and we would say this z-score is larger than this z-score, therefore this is a more unusual point than this one. Okay? So 3.225 is larger than 2.33. So the 6'2" woman is more unusual than the
6'5" man.
yeah, than the 6'5" man. Okay, and so I used examples here that kind of match your intuitive sense of heights and the like. Okay, but the same principles of z-scores and all of that can be adapted to situations where you're not so common, not so familiar. Okay, we could talk about what's more unusual, an elephant that weighs, this many pounds, or a giraffe that weighs this much, or what's more unusual, someone scoring this score on a test, or someone getting this, or something. Okay. So z-scores, this is our first exposure to them. They're going to come in, we're going to see them quite frequently throughout the course. So get a handle of that. On your homework, you've got some exercises. Be sure to work through all of them. Make sure you understand everything in the homework. On the homework page, I have a description of the things you need to know for the quiz for next week. Okay? So get here on time next week. We're going to try to start the quiz at 7 o'clock. see you.